Good day, viewers. You are welcome back to Tindanious Math and Science Tutorials. If you know you are new here, kindly visit my previous lecture videos on how to graph the piecewise functions. If you are new here, kindly share, like, comment and subscribe for more interesting videos and updates. You have a question on the board. Graph a function, sketch a graph of the function. F of x is given by this and that. So we are going to consider each graph or each function separately. After that, then what we'll bring them together or we'll merge them to get the overall graph of the function f of x, right? Good. So let's consider this. For x plus 1, this way. So we need our x values and we need our y values, right? So for this interval, x is less than or equal to 2. So that means I'll start from 2, then 2 reduces gradually, right? So to 1, 0, let's say negative 1, okay? So, look, I have x plus 1 to be the function. So if I have x to be equal to 2, and I add 1 to this, I'll get the corresponding y value, right? So 2 plus 1, I have 3. Because of this function. 1 plus 1, I have 2. Because of this relation. If I have 0 plus 1, I have 1. Then negative 1 plus 1, I have what? 0. So I'm going to plot this. So viewers, we now know the x and the corresponding y coordinates. So we are going to graph this. So let's plot this on the graph. So I have 2, 3. So let me do this way. I have 2, 3. So 2, 3 here. 2, 3. Then the next one I have 1, 2. Then I have 0, 2. This is 2, 3. This is 1, 2. This is 0, 1. Sorry. Then the last one I have negative 1, then 0. Let's plot this, okay? So 2, 3, 1, 2, 0, 1, negative 1, then 0. So I have 2, 3. So I have 2, then 3 here. So 2, then 3, somewhere here. Then I have 1 and 2, right? So 1, this 1. Then 2, somewhere here. Pardon me, it's not drawn to scale, okay? Then I have 0, 1. This is 0, right? Then 1, somewhere here. Then I have negative 1, 0. Negative 1, 0, somewhere here. What do? You draw a straight line to pass through this point, something like this. It's a straight line. As simple as that. Now viewers, look, for s is less than or equal to 2, right? Good. So if this is my 2 here, this is my 2, right? So that means I'm going to shade this what? This end point. So I'll erase this. Good. As simple as that. So that means this is the graph for this. X plus 1 for this interval. Right? As simple as that. Now we have this. 1 for x is greater than 2. This is very simple. Let's locate 1. Where is 1? This is 1. Right? So you can just draw a straight line this way. This is 1. As simple as that. Right? Now let's consider the condition. They say x is greater than 2. So that means this is defined this is valid. This will make sense when you have x to be greater than 2. So we need to obey the voice of the question. So where is x is greater than 2? So this is 2, right? Say greater than 2. So somewhere here. So when we say x is greater than 2, that means you are starting from what? From 3 and above. 3 and beyond, right? So let's somewhere here, okay? Good. So that means I'm going to start from here. Do you get it that way? Before I can now what? I can now draw my graph this way. Approaching this way, okay? As simple as that. So I can now erase this. And I can now what? Erase this because I don't need this. Because of what? Because of the inequality statement. Right? I'll erase this and the graph simply becomes this. This is it. As simple as that. So viewers, remember I will not shade this side because I don't have any what? So if I have a bar here, that means I'm going to shade that endpoint. Because I don't have it, I won't. You see here, we have a stroke here. You can see the bar here. So we had to what? We had to shade this. As simple as that. Viewers, let's consider the second question where I will combine functions like this and a quadratic function. Okay, all right.
Action.
Okay, viewers, let's consider the other question, which is this, right? Good. So it follows the same concept. But before I'll solve this question, okay? Before I'll hammer on this, let me just teach you one or two stuff, all right? Good. Viewers, you know here, the intercept is what? That's -1, right? From here we have -1, 0, right? So here, -1, right? Good. And here, the interval, s is greater than 2, right? So that means x should begin at what? 3 and beyond, right? This way. Now, if you want to start from 2, what do? You can decide to extend this to 2. But if you do it this way, you will be wrong. Okay? So if you want to extend it to 2 such that you will be correct, that means at the end point, you have to what? You have to add this. Is a circle that is not what? That is not shaded. So when we see this, we know that, oh, okay, you are starting from here, but it means we are not starting from 2. This simply means you are starting from what? From 3. Do you get that? So either you do it this way, or you erase this, then start from here. You are good to go. So whenever you see this in the other books, it still makes what? Sense. So this is the same as x is greater than 2. That means 2 is exclusive. In other words, 2 is not included. As simple as that. Let's consider the other question. Sketch a graph of the function f of x equals this. So we have a quadratic function, right? A constant function, and we have a straight line graph or a linear function. This is so simple. Viewers, we've been practicing this, so we know the shape of what? Of x squared. So x squared. So because we've been doing this, okay, from the beginning, we are now mature, okay? The maturity is high now, right? So if I have x squared and I want to graph this, I already know that x squared, when I graph it, it should behave this way. Then somewhere like this. As simple as that, right? Good. This is the graph of x squared. Now for the interval, listen. So if x is less than or equal to 1, let's obey that restrictions or the boundary. X is less than or equal to 1. Where is my 1? This is my 1. Viewers, this is my 1. So in other words, I have to end here. You see, I can't go beyond this. So I'll erase this. So if you do this for long, when you practice this for long period of time, you don't need to draw any table, right? Good. That's why we started from the scratch. We needed to draw tables and what have you, right? Good. Now we are mature, right? So I can just end over here. So I have 1. So somewhere here. Good. It will end here. Here. As simple as that. So ask yourself, is this shaded or not shaded? Remember, the x is less than or equal to 1. So the bar here simply tells me that what? That endpoint is shaded. So I have it to be this way, like this. It's shaded. As simple as that. Right? Good. So this is for x squared. Now, let's consider the horizontal function. Okay, this is a constant function. Okay, we have 3. If this interval, okay, is obeyed or satisfied, so I have 3, right? This is 3. Okay, I can simply draw this. This is 3. I don't need to draw any table, right? Good. Now, what is the interval? The interval is 3. If and only if 1 is less than x, less than or equal to 2. How do we satisfy this restrictions or this condition or this boundary or this set of intervals? So if I draw this, okay, this is my constant function, okay, x is equal to 3. Okay, so we have the function, okay, this, right? Y is equal to 3, right? Y equals 3. So this is how to graph it. So what do we do now? Having drawn this, fine. Is this defined or not? Let's obey this restriction. I have 1 less than or equal to x, less than or equal to 2. That means let's start from 1, okay, and end over here for now. So if I trace this is my 1, right? So I have 1 over here, 1 here. Then where? Up to positive 2. And this is what? Up to 2 here. 2. Do you get that? So in other words, I'll erase or I'll discard this here up to where I'll end here. Okay. So now let's ask ourselves 2. Before I get to the 2, you see you have what? You have a bar or a stroke here. So which indicates that what? This point is included. This point is inclusive. In other words, you will shade that end point because of this bar. Right? Good. So what happens to the 1? You can start from 1 this way, okay? I can just do this. I can open it at this end. And this is the interval. As simple as that. So when we see this, we already know that, oh, okay, you are starting from 1. But because of the open circle, that means 1 is not what? 1 is not included. As simple as that. So this is how you can graph your function without necessarily draw what? Tables, okay? Or charts. Let's consider the last one. Have x. In other words, x plus 0, right? This is a linear function. So you have x. So whenever you have graph of that nature, okay, it is just a simple straight line from the origin, right? So it's like x plus 0, this way, x plus 0, that's it, which is equal to what? Your x. So x plus 0, okay, so x, this is the nature of the graph, something like this, okay, then like this, as simple as that. So you have a straight line from the origin, but before we can make this function defined, let's obey the condition. So what? If x is greater than 2, right? Good. So if I do this, fine. So where is my 2? This is my 2 somewhere here. Somewhere here, right? Good. So if I draw this up to here, okay, it should be greater than 2. So viewers, so that means below 2 wouldn't make my function defined. So then I'm going to discard this and focus on the graph over here, because they says what? It should be greater than 2. It should be what? It should go beyond 2, right? So for that matter, I'll consider the graph this way. As simple as that. This way. Something like this. So now it said if s is greater than 2, right? So if I have it this way, now let's see what happens. We can do this because we are considering x to be greater than 2. So this is 2, right? To be greater than 2, what do? You move to 3, because 3 is greater than 2. So somewhere here, this way we should graph it. So I'll also I'll erase this. So x is greater than 2, all right? So that means when you have, so that means the negative values up to 2 wouldn't make the function defined. Why? Because they say x should be what? Should be greater than 2. So that means from here up to here, this 2, okay, this side, we don't need it, okay? It should be greater than 2, which is what? Which is 3. So to start from this side, okay? So here, somewhere here, good. This is it. As simple as that. So I have it this way. This is my graph. So viewers, what can we do now? What can we do now? There's nothing we can do here, right? So viewers, this is the end of the tutorials, okay? This is how we simply graph piecewise function. First of all, you consider the individual functions, okay? So other facilitators, or in other books we call it what? Segments. So you consider each segment, okay? Afterwards, combine the graph on a single sheet or a single what? Graph book, and that is what? The whole concept behind graph of piecewise function. If you find this tutorials very, very interesting, don't forget to share, like, comment and subscribe for more interesting videos and updates. Continue to practice, learn and practice what you study. Practice maths every day. Learn every day, because those who stop learning stop what? Living. All right? Bye.